Question 1. Considering the iterative framework of ISO 14031-2019 for assessing environmental performance, how does the identification of significant environmental aspects and their associated risks directly inform the selection of appropriate environmental performance indicators, EPI? Option A. EPIs should be chosen to directly monitor and reflect the progress in mitigating or managing the risks identified as significant through the environmental risk assessment process. Option B. EPIs are primarily selected based on regulatory compliance mandates, with risk assessment serving only as a secondary consideration for operational efficiency improvements. Option C. EPIs should focus exclusively on resource consumption metrics, as these are universally considered the most significant environmental risks across all industrial sectors, according to ISO 14031-2019. Option D. The risk assessment process is considered complete once significant aspects are identified, and EPIs are then independently developed to track general environmental improvements without a direct link to specific risks. Correct answer is A. EPIs should be chosen to directly monitor and reflect the progress in mitigating or managing the risks identified as significant through the environmental risk assessment process. Explanation. The core principle of ISO 14031-2019 regarding environmental risk assessment, specifically within the context of performance evaluation, emphasizes a proactive and systematic approach. The standard guides organizations to identify potential environmental aspects and their associated risks, not in isolation, but as they relate to the organization's operational activities, products, and services. This identification is then linked to the establishment of environmental objectives and targets. The subsequent evaluation phase involves determining the significance of these identified risks and aspects. This significance is typically assessed against criteria that include legal and other requirements, the organization's environmental policy, and the potential for environmental impact. The process is iterative, feeding back into the planning and operational control stages. When considering the relationship between identified environmental aspects, risk assessment, and performance indicators, the standard stresses that performance indicators should be chosen to monitor and measure progress towards achieving environmental objectives, which are often derived from the risk assessment process. Therefore, an environmental performance indicator that directly reflects the reduction or mitigation of a significant identified environmental risk, such as a decrease in the quantity of hazardous waste generated, a risk related to improper disposal, is a direct outcome of a well-integrated risk assessment and performance management system. This aligns with the standard's aim to improve environmental performance through informed decision-making based on risk understanding. Question 2. A manufacturing firm, Ethelred Alloys, has recently introduced an innovative closed-loop cooling system for its smelting operations, aiming to significantly reduce its freshwater intake. To gauge the efficacy of this new system, the environmental management team is tasked with selecting suitable indicators. Considering the principles outlined in ISO 14031-2019 for assessing environmental performance, which type of indicator would most directly reflect the operational efficiency and effectiveness of the Ethelred Alloys' new cooling system in managing its water resource aspect? Option A. Average monthly rainfall in the region where the facility is located. Option B. Number of days the facility operated without any reported spills of cooling lubricant. Option C. Liters of water consumed per ton of refined metal produced by the smelting operation. Option D. Concentration of specific heavy metals in the local river sediment downstream of the plant. The correct answer is C. Liters of water consumed per ton of refined metal produced by the smelting operation. Explanation. The scenario describes an organization that has implemented a new process to reduce its water consumption. To assess the effectiveness of this new process, the organization needs to select appropriate environmental performance indicators. EPI. ISO 14031-2019 distinguishes between different types of EPIs, including operational performance indicators (OPI) and environmental condition indicators (SI). OPIs measure the environmental performance of an organization's activities, products, and services, reflecting how efficiently resources are used or how well environmental impacts are controlled. SI, on the other hand, measure the state of the environment, either at a local, regional, or global level, and are influenced by the activities of many organizations and other factors. In this case, the organization wants to understand how well its new process is performing in terms of water usage. An indicator that directly measures the water consumed per unit of production or service delivered by this specific process is an OPI. This type of indicator provides direct feedback on the operational efficiency and the organization's control over its environmental aspect, water consumption. For example, liters of water consumed per kilogram of product manufactured would be a classic OPI. Conversely, an ECI would be an indicator of the state of a local river or aquifer, such as dissolved oxygen levels in the downstream river or groundwater table depth. While these ECIs might be indirectly affected by the organization's water usage, they are not direct measures of the organization's operational performance related to its new process, and are influenced by many other factors beyond the organization's control. Therefore, to assess the performance of the new process itself, an OPI is the most appropriate type of indicator. Question 3. Consider a global logistics company, SwiftShip, that operates a fleet of delivery vehicles and manages several distribution hubs. SwiftShip is developing its environmental performance assessment framework according to ISO 14031-2019. Which of the following metrics, when tracked by SwiftShip, most accurately represent an organizational environmental performance indicator, OPI, directly reflecting its operational impact and management control? Option A. The total volume of water contained within the river adjacent to SwiftShip's largest vehicle maintenance depot. Option B. The average number of hours of sunlight received daily at the location of SwiftShip's primary distribution center. Option C. The proportion of recycled content in the packaging materials used for shipments handled by SwiftShip's distribution hubs. Option D. The prevailing wind speed in the region where SwiftShip's delivery routes are most concentrated. The correct answer is C. The proportion of recycled content in the packaging materials used for shipments handled by SwiftShip's distribution hubs. Explanation: ISO 14031-2019 distinguishes between environmental performance indicators, EPI, and organizational environmental performance indicators, OPI. EPIs measure an organization's environmental performance relative to its environmental policy and objectives. OPIs are a subset of EPIs that are directly related to the organization's activities, products, and services, and are used to assess the environmental performance of the organization itself. For instance, a manufacturing plant's total energy consumption for its production processes is an OPI, as it directly reflects the operational efficiency and environmental impact of the plant. However, the ambient air quality in the region surrounding the plant, while influenced by the plant's emissions, is an environmental condition indicator, SI, not an OPI, because it measures the state of the environment, not the organization's direct performance in relation to its operations. Similarly, the amount of recycled material purchased by the organization is an OPI, as it reflects a direct organizational decision and action impacting its environmental performance. The total volume of water in a nearby river is an ECI. The quantity of hazardous waste generated by the organization's internal processes is an OPI. The level of a specific pollutant in a downstream water body is an ECI. Therefore, identifying OPIs involves focusing on metrics that quantify the inputs, outputs, and processes directly controlled or influenced by the organization's activities. Question 4. A manufacturing firm, Veridian Dynamics, is committed to reducing its overall environmental footprint. To gauge progress and identify areas for proactive intervention, the environmental management team is developing a suite of environmental performance indicators. They are particularly interested in indicators that demonstrate the effectiveness of their internal environmental management system initiatives and predict future improvements in operational efficiency and impact reduction. Considering the principles of ISO 14031-2019, which of the following indicators would best serve as a leading indicator for Veridian Dynamics' efforts to enhance its environmental performance? Option A. The average energy consumption per unit of output over the last financial quarter. Option B. The number of environmental compliance audits conducted by regulatory bodies in the past 2 years. Option C. The percentage of production batches that successfully met the internal waste reduction target in the previous month. Option D. the total quantity of recycled materials incorporated into new product designs during the last fiscal year. Correct answer is C. The percentage of production batches that successfully met the internal waste reduction target in the previous month. Explanation: ISO 14031, 2019 emphasizes the use of environmental performance indicators, EPI, to assess an organization's environmental performance. These indicators are categorized into direct and indirect. Direct EPIs measure an organization's environmental aspects and their impacts, such as emissions or waste generation. Indirect EPIs, on the other hand, relate to an organization's management systems and their effectiveness in influencing environmental performance. Leading indicators are proactive and predictive, aiming to anticipate future environmental performance by monitoring activities and management efforts. Lagging indicators are reactive and historical, measuring past environmental performance outcomes. For instance, the number of environmental training sessions conducted for employees is a leading indicator, reflecting management's commitment to environmental awareness. Conversely, the total volume of hazardous waste sent for disposal in the previous fiscal year is a lagging indicator, reflecting past operational outcomes. An organization seeking to improve its water consumption would monitor both. A leading indicator might be the percentage of employees who have completed water conservation training, while a lagging indicator would be the total cubic meters of water consumed in the past quarter. The former helps gauge the effectiveness of awareness programs and predict future behavioral changes that could lead to reduced consumption, whereas the latter confirms past performance. The question asks for an indicator that reflects proactive management efforts and the potential for future performance improvement, which aligns with the definition of a leading indicator. Question 5. Consider an industrial manufacturing firm operating under stringent national regulations that mandate a phased reduction in volatile organic compound (VOC) emissions. The firm's environmental policy expresses a commitment to exceeding regulatory minimums for air quality. When establishing an environmental objective and associated target for VOC emissions, which of the following approaches best reflects the principles outlined in ISO 14031, 2019 for setting meaningful and actionable environmental performance indicators? Option A. Create an objective to innovate in emission control technologies and a target to invest in research and development for new abatement methods, without a direct link to current emission reduction performance. Option B. Set an objective to improve air quality and a target to conduct annual emissions monitoring without specifying a quantitative reduction goal. Option C. Define an objective to comply with all air quality regulations and set a target to meet the 10% VOC reduction required by law by the stipulated deadline. Option D. Establish an objective to significantly decrease VOC emissions and set a target of reducing VOC emissions by 20% from the previous year's levels within the next fiscal year, ensuring this exceeds the legally mandated reduction. Correct answer is D. Establish an objective to significantly decrease VOC emissions and set a target of reducing VOC emissions by 20% from the previous year's levels within the next fiscal year, ensuring this exceeds the legally mandated reduction. Explanation: ISO 14031, 2019 emphasizes that environmental objectives and targets should be established for significant environmental aspects. These objectives represent the desired environmental performance level, while targets are specific, measurable, achievable, relevant, and time-bound. SMART criteria used to achieve those objectives. When setting an environmental objective related to reducing waste generation, a key consideration is to align it with the organization's overall environmental policy and legal obligations, such as national waste management regulations. For instance, if a company's policy commits to minimizing landfill waste and current legislation mandates a 15% reduction in non-hazardous industrial waste sent to landfills by a specific future date, the objective might be to reduce non-hazardous industrial waste sent to landfill. The corresponding target would then be a quantifiable measure, like achieve a 15% reduction in non-hazardous industrial waste sent to landfill by December 31, 2025, compared to the 2023 baseline. This ensures the objective is both ambitious and directly linked to regulatory compliance and policy commitment, demonstrating a clear pathway for improving environmental performance. The process involves identifying significant aspects, setting clear objectives, and then defining specific, measurable targets that drive progress towards those objectives, all within the framework of the organization's environmental management system. Question 6. Consider an organization that has a well-established quality management system, conforming to ISO 9001-2015. To enhance its environmental performance assessment according to ISO 14031-2019, how can the organization most effectively integrate its EPE processes within the existing QMS framework to achieve operational synergy and avoid duplication of effort? Option A. Prioritize the integration of environmental aspects only within the corrective action and nonconformance reporting mechanisms of the QMS, while keeping other EPE activities siloed. Option B. Develop entirely new, separate processes for environmental performance evaluation that are documented and managed independently from the quality management system to ensure distinct focus. Option C. Focus solely on updating the environmental policy to reflect new performance goals, without altering the fundamental operational procedures or review cycles of the existing quality management system. Option D. Adapt existing QMS procedures for data collection, monitoring, internal auditing, and management review to incorporate environmental performance indicators and targets, leveraging common management system elements. The correct answer is D. Adapt existing QMS procedures for data collection, monitoring, internal auditing, and management review to incorporate environmental performance indicators and targets, leveraging common management system elements. Explanation. ISO 14031-2019 emphasizes the integration of environmental performance evaluation, (EP), with other management systems to achieve synergistic benefits and a holistic approach to organizational management. When integrating EPE with an existing quality management system, QMS, based on ISO 9001-2015, the focus is on leveraging established processes and documentation for enhanced efficiency and effectiveness. The key consideration is how the EPE framework, which involves establishing environmental performance indicators, (EPI), and monitoring them, can be embedded within the QMS's planning, operation, and review cycles. This integration allows for the use of existing data collection mechanisms, audit procedures, and management review processes to incorporate environmental aspects. For instance, the process of identifying customer requirements in QMS can be extended to include stakeholder expectations regarding environmental performance. Similarly, the nonconformance and corrective action procedures within a QMS can be adapted to address environmental performance issues identified through EPE. The standard encourages a systematic approach where EPE principles inform and are informed by other management system elements, leading to a more robust and comprehensive environmental management strategy that aligns with overall business objectives. The integration aims to avoid duplication of effort and to ensure that environmental considerations are a natural part of the organization's core operations and decision-making processes, rather than being treated as a separate, isolated activity. This aligns with the principles of integrated management systems, where common elements such as context of the organization, leadership, planning, support, operation, performance evaluation, and improvement are shared across different management system standards. Question 7. A metal fabrication plant, operating under stringent local air quality regulations that limit specific volatile organic compound, VOC, emissions from its painting booth, needs to establish a robust environmental performance assessment for this operational area. Considering the need for accurate, verifiable data to demonstrate compliance and identify opportunities for process optimization, which measurement technique would be most aligned with the principles of ISO 14031-2019 for evaluating the environmental performance related to VOC emissions? Option A. Benchmarking the plant's VOC emission intensity against the average of similar facilities in a different geographical region. Option B. Conducting an annual qualitative survey of employee awareness regarding VOC reduction strategies. Option C. Estimating VOC emissions based on the total volume of paint solvents consumed annually and applying generic emission factors. Option D. Implementing continuous emission monitoring systems, SEMS, on the exhaust stack of the painting booth to quantify VOC concentrations in real time. The correct answer is D. Implementing continuous emission monitoring systems, SEMS, on the exhaust stack of the painting booth to quantify VOC concentrations in real time. Explanation: the selection of appropriate measurement techniques under ISO 14031-2019 hinges on the specific environmental aspect or condition being assessed and the intended use of the data. For manufacturing facility aiming to track air emissions of volatile organic compounds, VOC, a direct measurement technique that quantifies the concentration of VOCs in the exhaust stack is most suitable. This involves using continuous emission monitoring systems, SEMS, or periodic stack testing. SEMS provide real-time data, allowing for immediate identification of deviations from permitted limits, which is crucial for compliance with regulations like the Clean Air Act. Periodic stack testing, while less frequent, offers a detailed analysis of emission profiles. The explanation for why this is the correct approach involves understanding that ISO 14031 emphasizes the relevance and reliability of data for environmental performance evaluation. Direct measurement directly addresses the emission source and provides quantifiable data relevant to regulatory compliance and performance improvement. Indirect methods, such as material balance calculations, might be used for estimation, but lack the precision and directness required for robust performance assessment of specific emissions. Benchmarking against industry averages or using qualitative assessments are also part of a broader environmental management system, but do not constitute the primary measurement technique for specific emission parameters. Therefore, a direct, quantifiable measurement of VOCs in the exhaust stack is the most appropriate technique for this scenario. Question 8. A manufacturing firm operating under stringent national air quality regulations that mandate reductions in volatile organic compound, VOC, emissions, is evaluating potential environmental performance indicators to track progress. Their primary environmental aspect identified is air emissions. Considering the criteria outlined in ISO 14031-2019 for selecting effective EPIs, which of the following indicators would be the most appropriate for this organization to adopt? Option A: the number of reported minor air quality incidents related to fugitive emissions, irrespective of their VOC content. Option B: the percentage of employee training hours dedicated to environmental awareness programs, regardless of specific emission reduction activities. Option C: total mass of VOCs emitted annually, normalized by the total production output for that year. Option D: the total volume of water used in the facility's cooling towers, as water management is also a key operational area. The correct answer is C: total mass of VOCs emitted annually, normalized by the total production output for that year. Explanation: ISO 14031-2019 emphasizes the selection of environmental performance indicators, EPI, that are relevant to the organization's environmental aspects and impacts, and that can be reliably measured. Relevance ensures that the EPI directly reflects an aspect of the organization's environmental performance that is significant. Measurability means that the data required to calculate the EPI can be collected and processed in a consistent and accurate manner. Accuracy implies that the collected data accurately represents the phenomenon being measured, minimizing bias and error. Comparability allows for tracking performance over time, benchmarking against similar organizations or industry standards, and evaluating the effectiveness of environmental management initiatives. For an EPI to be effective, it must possess a high degree of relevance to the environmental aspect being monitored, such as emissions of a specific pollutant. It must also be measurable, meaning that the data needed to calculate it can be collected systematically and without undue burden. Furthermore, the data must be accurate, reflecting the true state of the environmental aspect. Finally, comparability is crucial for trend analysis and benchmarking, enabling the organization to understand its performance in a broader context. An EPI that is difficult to measure or lacks accuracy, even if relevant, will not provide reliable insights for management decisions. Similarly, an EPI that is easily measured but not relevant to the organization's significant environmental aspects will not effectively guide performance improvement. Question 9. Consider a specialized aerospace component manufacturer that utilizes a complex curing process involving proprietary chemical compounds. The company is subject to stringent national regulations regarding airborne particulate matter and volatile organic compound, VOC, emissions, with specific permissible limits defined by the Environmental Protection Agency. When selecting environmental performance indicators, EPI, according to ISO 14031, 2019, to assess the environmental performance of its curing operations, which of the following combinations of EPIs would best reflect both direct environmental releases and operational efficiency in relation to production output? Option A. Total annual VOC emissions in kilograms and VOC emissions in grams per kilogram of finished component produced. Option B. Total greenhouse gas emissions in metric tons of CO2 equivalent and the number of employee environmental awareness training sessions held. Option C. Total energy consumed in kilowatt hours and the number of regulatory compliance audits conducted annually. Option D. Total water consumed in liters and the percentage of waste recycled from the curing process. The correct answer is A. Total annual VOC emissions in kilograms and VOC emissions in grams per kilogram of finished component produced. Explanation: ISO 14031-2019 emphasizes the selection of environmental performance indicators, EPI, that are relevant, reliable, and provide meaningful insights into an organization's environmental performance. The standard categorizes EPIs into direct and indirect types. Direct EPIs measure an organization's environmental releases to the environment, e.g., tons of CO2 emitted. Indirect EPIs measure factors that influence environmental performance but are not direct releases, e.g., energy consumed per unit of production. When selecting EPIs, an organization must consider its significant environmental aspects, operational context, legal requirements, such as emission limits set by national environmental protection agencies or regional air quality standards, and the intended use of the data. The principle is to choose indicators that help understand, manage, and improve environmental performance. For company manufacturing advanced composite materials, a key operational aspect is the use of solvents in curing processes, which can lead to volatile organic compound, VOC, emissions. A direct EPI would be the total mass of VOCs released annually. However, to understand the efficiency of solvent use and the impact of production volume on emissions, an indirect EPI is also crucial. This indirect EPI would relate the VOC emissions to the amount of product manufactured. For instance, kilograms of VOCs emitted per ton of composite material produced. This provides a measure of efficiency and allows for comparison across different production batches or over time, irrespective of production volume changes. This approach aligns with the standard's guidance on using EPIs to assess performance trends and identify areas for improvement. The selection should also consider the availability and reliability of data collection methods. Question 10. Consider a large textile manufacturing facility operating under stringent national environmental regulations concerning water discharge quality. The facility employs several dyeing processes, each with varying water consumption and effluent characteristics. Which of the following environmental performance indicators would be classified as an operational performance indicator, OPI, according to ISO 14031, 2019 guidelines, specifically focusing on the direct operational impact of these dyeing processes? Option A. Liters of treated wastewater discharged per kilogram of dyed fabric. Option B. Number of internal audits conducted on the wastewater treatment plant's operational procedures. Option C. Percentage reduction in the overall energy consumption of the dyeing department compared to the previous fiscal year. Option D. Ambient concentration of heavy metals in the river downstream of the facility. The correct answer is A. Liters of treated wastewater discharged per kilogram of dyed fabric. Explanation: ISO 14031, 2019 distinguishes between three types of environmental performance indicators: EPI, direct environmental indicators DE, indirect environmental indicators EI, and management environmental indicators ME. Operational performance indicators, OPI, are a subset of DEIs that measure the environmental aspects of an organization's operations. These indicators focus on the inputs, outputs, and emissions directly associated with specific activities or processes. For instance, the quantity of a specific hazardous chemical consumed per unit of product manufactured is an OPI. This type of indicator directly reflects the environmental burden of an operational process. In contrast, IEIs relate to broader environmental conditions influenced by an organization, such as ambient air quality in the vicinity of a facility, which is not directly controllable by a single operational unit. May, on the other hand, assess the extent to which an organization's management system is implemented and functioning, such as the number of environmental training sessions conducted. Therefore, an indicator that quantifies the amount of water used per hour of production in a manufacturing plant is a direct measure of operational efficiency and environmental impact, fitting the definition of an OPI. Question 11. When an organization is evaluating the advantages of adopting the systematic approach to environmental performance assessment detailed in ISO 14031-2019, which specific benefit is most directly supported by the framework's emphasis on selecting and monitoring relevant environmental performance indicators? Option A. Enhanced ability to track progress towards environmental objectives and targets, facilitating data-driven decision-making for continuous improvement. Option B. Direct qualification for international environmental certifications without further auditing processes. Option C. Reduced costs associated with waste disposal due to a mandatory government mandate on recycling rates. Option D. Improved public perception and brand image solely through the publication of annual environmental reports. The correct answer is A. Enhanced ability to track progress towards environmental objectives and targets, facilitating data-driven decision-making for continuous improvement. Explanation. ISO 14031-2019 provides a framework for organizations to assess their environmental performance. The standard emphasizes the importance of selecting appropriate environmental performance indicators, EPI, that are relevant to the organization's impacts and aspects. The primary benefit of implementing a robust EPI system, as outlined in ISO 14031, is to enable an organization to track its progress towards environmental objectives and targets. This tracking allows for informed decision-making regarding environmental management strategies, resource allocation, and the identification of areas for improvement. By systematically monitoring EPIs, an organization can gain insights into the effectiveness of its environmental programs, identify trends, and demonstrate accountability to stakeholders. This continuous improvement cycle, driven by data from EPIs, is central to enhancing overall environmental performance. Furthermore, the selection of appropriate EPIs, which can include both operational and management types, facilitates a comprehensive understanding of how organizational activities influence the environment and how management practices can mitigate negative impacts. The standard guides organizations in establishing and maintaining a system for evaluating environmental performance, which ultimately supports the achievement of environmental policy commitments and regulatory compliance, such as those stipulated by national environmental protection agencies. Question 12. An environmental management team is evaluating its performance metrics according to ISO 14031-2019. They are considering a metric that quantifies the average concentration of particulate matter, PM2.5, in the air within a 5-kilometer radius of their primary manufacturing plant. This measurement is taken from publicly accessible monitoring stations and is influenced by a variety of local sources, including traffic, other industrial facilities, and residential heating, in addition to the plant's own emissions. Which category of environmental performance indicator, as defined by ISO 14031-2019, best describes this specific metric? Option A. Direct environmental impact indicator. Option B. Environmental condition indicator. Option C. Management performance indicator. Option D. Operational performance indicator. The correct answer is B. Environmental condition indicator. Explanation. ISO 14031-2019, in its framework for assessing environmental performance, distinguishes between different types of indicators. An environmental condition indicator measures the state of the environment itself, independent of specific organizational activities. For instance, ambient air quality levels or the biodiversity index of a local ecosystem would be environmental condition indicators. An environmental performance indicator, on the other hand, directly relates to an organization's management of its environmental aspects. These are further categorized into management performance indicators, MPI, and operational performance indicators, OPI. MPIs reflect the extent to which an organization controls its environmental impacts through management systems and actions, such as the number of environmental training sessions conducted or the percentage of environmental policies reviewed. OPI, however, measure the environmental impact of an organization's activities, products, and services, often expressed in terms of resource use or emissions. Examples include the energy consumed per unit of production or the volume of wastewater discharged per ton of product. Therefore, a measure of the concentration of a specific pollutant in the air surrounding a manufacturing facility, if it reflects the general state of the local atmosphere rather than solely the facility's direct emissions contribution to that specific concentration, would be classified as an environmental condition indicator. Question 13. When employing life cycle assessment, LCA, to identify environmental aspects and their associated impacts for a sophisticated semiconductor manufacturing facility, which methodological step within the LCA framework is most critical for comprehensively capturing the diverse environmental interactions stemming from raw material sourcing through to end-of-life product management? Option A. Forming a qualitative risk assessment of potential environmental hazards associated with each identified process stage. Option B. Conducting a detailed life cycle inventory analysis to quantify all material and energy flows throughout the entire value chain. Option C. Engaging in stakeholder consultations to gather input on perceived environmental concerns related to the manufacturing process. Option D. Developing a set of specific environmental performance indicators, EPI, tailored to the unique operational context of the facility. The correct answer is B. Conducting a detailed life cycle inventory analysis to quantify all material and energy flows throughout the entire value chain. Explanation. ISO 14031, 2019 provides guidelines for assessing environmental performance, emphasizing the identification of environmental aspects and their associated impacts. A life cycle assessment, LCA, is a key tool for this, enabling a comprehensive evaluation of a product or service's environmental footprint from cradle to grave. When using LCA to identify environmental aspects and impacts for an organization's operations, the focus is on understanding the inputs and outputs of the system and their potential consequences on the environment. For instance, in the manufacturing of electronic components, LCA would consider raw material extraction, energy consumption during production, transportation, product use, and end-of-life disposal. Environmental aspects are the elements of an organization's activities, products, or services that can interact with the environment, such as energy consumption, water usage, or emissions. Environmental impacts are the changes to the environment, whether adverse or beneficial, wholly or partially resulting from an organization's environmental aspects. The process involves defining the goal and scope of the LCA, conducting an inventory analysis, collecting data on inputs and outputs, performing an impact assessment, evaluating the potential environmental impacts, and interpreting the results. The most effective approach for identifying a broad range of potential environmental aspects and their associated impacts, particularly for a complex manufacturing process like semiconductor fabrication, is to systematically map all material and energy flows throughout the entire life cycle, from raw material acquisition to final disposal or recycling. This systematic mapping allows for the identification of specific activities, such as the use of hazardous chemicals in etching processes, the generation of wastewater with dissolved metals, or the consumption of large amounts of electricity, which are then linked to potential environmental impacts like water pollution, soil contamination, or greenhouse gas emissions. Therefore, a comprehensive life cycle inventory analysis, which quantifies all relevant inputs and outputs, is foundational to accurately identifying environmental aspects and their associated impacts according to ISO 14031, 2019 principles. Question 14. Consider an industrial facility that has successfully implemented separate management systems for environmental performance, aligned with ISO 14031, 2019, quality assurance, and occupational health and safety. To optimize resource allocation and enhance overall organizational efficiency, the leadership is exploring the integration of these systems. Which of the following outcomes best represents a significant, synergistic benefit of successfully integrating these management systems into a unified framework? Option A. streamlined operational procedures, and reduced administrative overhead due to the consolidation of common management system elements, leading to more efficient resource deployment. Option B, a mandatory shift in all company policies to prioritize environmental objectives above all other strategic business goals, irrespective of operational feasibility. Option C, a complete elimination of all environmental noncompliance issues and a guaranteed reduction in all operational costs by at least 20% within the first year of integration. Option D, the development of a solely environmental reporting structure that supersedes all other organizational reporting requirements, focusing exclusively on environmental metrics. The correct answer is A, streamlined operational procedures and reduced administrative overhead due to the consolidation of common management system elements, leading to more efficient resource deployment. Explanation: the integration of an environmental management system, EMS, with other management systems, such as quality ISO 9001 or occupational health and safety ISO 45001, can lead to synergistic benefits. ISO 14031-2019 emphasizes the assessment of environmental performance, which is intrinsically linked to operational efficiency and overall organizational performance. When an EMS is integrated, common elements like policy development, objective setting, management review, internal auditing, and document control can be streamlined. This reduces duplication of effort and resources, leading to cost savings. Furthermore, a unified approach enhances communication and coordination across different departments, fostering a more cohesive organizational culture. It also provides a more holistic view of the organization's impacts and performance, enabling better decision-making and continuous improvement across all aspects of management. This integration supports a more efficient allocation of resources and a clearer understanding of how environmental performance contributes to broader business objectives, such as improved reputation, reduced regulatory risk, and enhanced stakeholder engagement. For instance, integrating an EMS with a quality management system can lead to the development of more robust processes that inherently minimize waste and resource consumption, thereby improving both environmental performance and product quality. Question 15. When an organization utilizes environmental condition indicators, SI, as part of its environmental performance assessment framework, in alignment with ISO 14031-2019, what is the most direct and appropriate application of these indicators? Option A, to reflect the state of the environment and provide context for the organization's environmental performance. Option B, to directly measure the internal efficiency of the organization's resource utilization processes. Option C, to serve as the sole determinant of compliance with all relevant environmental legislation. Option D, to quantify the immediate reduction in the organization's operational waste streams. The correct answer is A, to reflect the state of the environment and provide context for the organization's environmental performance. Explanation: ISO 14031-2019 emphasizes the assessment of environmental performance through the use of various indicators. Environmental condition indicators, SI, are specifically designed to reflect the state of the environment. When an organization uses ECIs to assess its environmental performance, the primary objective is to understand the impact of its activities on the surrounding environment, not to directly measure its own operational efficiency or the effectiveness of specific internal processes. ECIs provide context for the organization's environmental performance by indicating changes in environmental quality, such as air or water pollution levels, biodiversity status, or land degradation. Therefore, linking ECIs to the direct reduction of an organization's own resource consumption or waste generation would be a misapplication of their purpose. Instead, ECIs help an organization determine if its activities are contributing to or mitigating broader environmental issues, thereby informing strategic environmental management decisions and the setting of relevant environmental objectives and targets that consider the broader environmental context. The effectiveness of an ECI lies in its ability to reflect the condition of the environment, which in turn can be influenced by the collective actions of many entities, including the reporting organization. Question 16. When evaluating an organization's adherence to ISO 14031-2019 principles for environmental performance assessment, Which of the following most accurately defines the core characteristic of an operational performance indicator (OPI) in relation to an organization's activities? Option A. A benchmark used to compare the organization's environmental performance against industry-wide regulatory compliance standards. Option B. A measure reflecting the overall quality of the natural environment in the vicinity of the organization's facilities. Option C. A metric that quantifies the direct environmental impact of specific operational processes or activities. Option D. An indicator assessing the effectiveness of the organization's environmental management system, policies, and procedures. Correct answer is C. A metric that quantifies the direct environmental impact of specific operational processes or activities. Explanation: ISO 14031-2019 provides guidelines for environmental performance evaluation. It distinguishes between different types of indicators used to assess an organization's environmental performance. Operational performance indicators, OPI, are internal measures that reflect the environmental performance of an organization's operations. They are directly linked to the activities, products, and services of the organization. Examples include the amount of a specific chemical used per unit of production, energy consumed per hour of operation, or waste generated per batch. The purpose of OPIs is to help an organization manage its environmental aspects and improve its environmental performance by providing actionable data on operational efficiency and impact. They are distinct from environmental condition indicators, which measure the state of the environment, and management performance indicators, which assess the effectiveness of the environmental management system itself. Therefore, an OPI focuses on the direct relationship between operational inputs and outputs and their environmental consequences. Question 17. A manufacturing firm, Veridian Dynamics, has set a target to reduce its specific energy consumption per ton of product by 15% within 2 years, based on its 2023 baseline. After the first year, their actual specific energy consumption has decreased by only 8%. According to the principles outlined in ISO 14031-2019 for assessing environmental performance against objectives and targets, what is the most appropriate immediate management action required by Veridian Dynamics? Option A. Focus solely on reporting the achieved 8% reduction in the next environmental performance review as progress is being made. Option B. Conduct a detailed root cause analysis of the performance gap and implement corrective actions to accelerate progress towards the target. Option C. Initiate a new environmental performance evaluation cycle from scratch, disregarding the previous year's data and target. Option D. Revise the environmental objective to align with the current rate of progress, making the 15% reduction target more achievable. Correct answer is B. Conduct a detailed root cause analysis of the performance gap and implement corrective actions to accelerate progress toward the target. Explanation: the core principle of ISO 14031-2019 concerning the assessment of environmental performance against objectives and targets is to establish a clear framework for monitoring progress and identifying deviations. This involves setting specific, measurable, achievable, relevant, and time-bound, SMART, objectives and targets. When evaluating performance, an organization must compare its actual environmental performance data against these established benchmarks. If the actual performance falls short of the target, or if the trend indicates a potential to miss the target, corrective actions are necessary. These actions are aimed at understanding the root cause of the deviation and implementing measures to bring the performance back in line with the objective. This iterative process of monitoring, comparing, and adjusting is fundamental to the continuous improvement cycle mandated by environmental management systems. For instance, if a company targets a 10% reduction in water consumption per unit of production by the end of the fiscal year, and after 9 months, the reduction is only 5%, this indicates a need for intervention. The organization would then analyze the factors contributing to this shortfall, such as inefficient equipment, changes in production processes, or inadequate employee training, and implement appropriate corrective measures. The emphasis is on proactive identification of performance gaps and timely implementation of solutions, rather than simply reporting the final outcome. This aligns with the standard's guidance on using environmental performance evaluation to inform management decisions and improve overall environmental performance. Question 18. An industrial facility operating under stringent regional air quality regulations akin to the Clean Air Act in the United States is evaluating its environmental performance. The organization has identified significant air emissions as a key environmental aspect and has set an objective to reduce particulate matter (PM2.5) emissions by 15% within 2 fiscal years. To monitor progress, they are considering various performance indicators. Which of the following approaches best aligns with the principles of ISO 14031-2019 for assessing the organization's direct environmental performance related to this objective? Option A. Assessing the public perception of air quality in the local community through surveys in relation to the facility's operations. Option B. Quantifying the number of regulatory exceedances for PM2.5 over a given period without considering production levels. Option C. Tracking the concentration of PM2.5 in the ambient air surrounding the facility correlated with operational output. Option D. Measuring the total volume of PM2.5 emitted from the facility stacks, normalized by the production volume of its primary product. The correct answer is C. Tracking the concentration of PM2.5 in the ambient air surrounding the facility correlated with operational output. Explanation. The core of ISO 14031-2019 is the Environmental Performance Evaluation (EP) framework, which guides organizations in assessing and improving their environmental performance. This framework involves establishing environmental objectives and targets, selecting appropriate environmental performance indicators (EPI), collecting and analyzing data related to these EPIs, and reporting on the findings. The standard emphasizes the distinction between environmental conditions, the state of the environment, and the organization's environmental performance, the results of its activities, products, and services on the environment. Environmental performance indicators are crucial for this assessment. They can be categorized into direct and indirect indicators. Direct environmental performance indicators measure the environmental aspects directly controlled by the organization, such as energy consumption per unit of production or waste generated per process. Indirect environmental performance indicators, on the other hand, relate to the environmental conditions that are influenced by the organization but not directly controlled, such as the impact of a company's emissions on local air quality or the effect of its water discharge on a river's biodiversity. The standard also highlights the importance of using a variety of EPIs to provide a comprehensive view of performance. When assessing the effectiveness of an environmental management system, particularly in relation to legislative compliance and internal operational improvements, the focus is on how well the organization is managing its environmental aspects and achieving its stated environmental objectives. This involves understanding the relationship between organizational activities and their environmental consequences, and using this understanding to drive improvements. The selection of EPIs should be driven by the organization's environmental policy, objectives, targets, and significant environmental aspects, as well as legal and other requirements. For instance, a manufacturing plant aiming to reduce its carbon footprint would likely select EPIs related to greenhouse gas emissions, energy efficiency, and potentially the life cycle impacts of its products. The EPE framework is a dynamic process, requiring ongoing monitoring, review, and adaptation to changing circumstances and knowledge. Question 19. Consider a manufacturing firm, Ether Dynamics, that has implemented an EMS aligned with ISO 14001. They are now seeking to deeply integrate their environmental performance evaluation (EPI) process, as guided by ISO 14031-2019, to enhance the overall effectiveness of their EMS. Which of the following approaches best exemplifies the strategic integration of EPE findings into the EMS for continuous improvement, considering the feedback mechanisms inherent in environmental management standards? Option A. Conducting a comprehensive EPE study once every 5 years and using its findings to create a separate, standalone report that is archived for regulatory compliance purposes. Option B. Utilizing EPE to benchmark against industry competitors without establishing internal feedback loops to modify the organization's own EMS based on the performance data. Option C. Systematically feeding EPE data, such as energy consumption trends and waste generation rates, into the management review process to inform the setting of new environmental objectives and targets, and to adjust operational controls. Option D. Focusing EPE solely on identifying significant environmental aspects without linking the performance data back to the operational controls or the overall strategic direction of the EMS. The correct answer is C. Systematically feeding EPE data, such as energy consumption trends and waste generation rates, into the management review process to inform the setting of new environmental objectives and targets, and to adjust operational controls. Explanation: the core of integrating environmental performance evaluation (EP) into an existing environmental management system (EMS), as outlined by ISO 14031-2019, lies in establishing a feedback loop for continuous improvement. EP, as defined in the standard, is a process that uses indicators to evaluate environmental performance relative to an organization's environmental policy, objectives, and targets. When integrating EPE into an EMS, the focus is on how the information generated from EPE informs and enhances the EMS's planning, implementation, checking, and review phases. Specifically, the data derived from EPE, such as trends in resource consumption or emissions, should directly feed into the review of the EMS, leading to the identification of areas for improvement, the revision of objectives and targets, and the adjustment of operational controls. This iterative process ensures that the EMS remains relevant and effective in managing environmental aspects and improving environmental performance. The standard emphasizes that EPE should be an ongoing activity, not a one-off assessment, and its results are crucial for management review, which is a key component of any robust EMS, including those aligned with ISO 14001. Therefore, the most effective integration ensures that EPE outputs are systematically used to drive changes and refinements within the EMS framework. Question 20. A manufacturing facility operating under stringent regional environmental regulations concerning volatile organic compound (VOC) emissions is implementing an enhanced environmental management system aligned with ISO 14031-2019. The facility's environmental manager is tasked with selecting appropriate environmental performance indicators to monitor progress and identify areas for improvement. Considering the facility's commitment to proactive environmental stewardship and regulatory compliance, which of the following indicators would best serve as a leading indicator for managing VOC emissions? Option A. The percentage of production shifts where all preventative maintenance checks on VOC abatement equipment were completed on schedule. Option B. The total quantity of VOC-containing raw materials purchased during the current operational period. Option C. The total volume of VOCs emitted in the preceding quarter, as measured by continuous emission monitoring systems. Option D. The number of documented environmental compliance audits conducted by external regulatory bodies in the last fiscal year. The correct answer is C. The total volume of VOCs emitted in the preceding quarter, as measured by continuous emission monitoring systems. Explanation: ISO 14031-2019 emphasizes the use of environmental performance indicators, EPI, to assess an organization's environmental performance. These indicators are categorized as either direct or indirect. Direct EPIs measure the environmental condition or the actual environmental impact of an organization's activities, products, or services. Indirect EPIs, on the other hand, measure the management efforts and the extent to which an organization is addressing its environmental aspects. Within the broader classification of EPIs, the standard distinguishes between leading and lagging indicators. Lagging indicators report on past events and are often reactive, indicating the results of past actions or inactions. For example, the total amount of hazardous waste generated in the previous fiscal year is a lagging indicator of waste management performance. Leading indicators, conversely, are proactive and predictive, aiming to identify potential future environmental performance issues or successes. They focus on the inputs, activities, and processes that influence environmental outcomes. Examples include the percentage of employees trained on environmental procedures, the number of preventative maintenance checks performed on pollution control equipment, or the proportion of new products designed with life cycle assessment principles. A robust environmental management system utilizes both types of indicators to gain a comprehensive understanding of performance enabling both the evaluation of past results and the anticipation and management of future environmental impacts. The question asks to identify which of the provided indicators is a leading indicator. Examining each option, we need to determine which one reflects a proactive effort or input that is intended to influence future environmental performance, rather than a measure of past results. Question 21. An industrial facility, Veridian Dynamics, is initiating its first comprehensive environmental performance assessment under ISO 14031-2019. The facility operates in a region with a significant protected wetland adjacent to its property, and its primary product involves a chemical process that historically generated air emissions. The company's management is focused on compliance with national air quality regulations and reducing operational costs. Which of the following stakeholder groups, if overlooked during the initial identification phase for the EPA, would most significantly undermine the assessment's credibility and completeness according to the principles of ISO 14031-2019? Option A. Employees in the Research and Development Department responsible for process innovation. Option B. Local community residents living downstream from the facility's wastewater discharge point. Option C. Shareholders primarily concerned with the company's financial stability and dividend payouts. Option D. Competitors operating in the same industrial sector. The correct answer is B. Local community residents living downstream from the facility's wastewater discharge point. Explanation: ISO 14031-2019 emphasizes the identification of stakeholders to ensure that the Environmental Performance Assessment (EPA) process is comprehensive and considers all relevant perspectives. Stakeholders are individuals or groups who can be affected by, or perceive themselves to be affected by an organization's environmental activities, products, or services. The standard advises organizations to establish a systematic process for identifying and engaging with these stakeholders. This process should consider both internal stakeholders, e.g., employees, management, and external stakeholders, e.g., customers, suppliers, regulators, local communities, non-governmental organizations, investors. The level of detail and the specific methods used for identification and engagement should be proportionate to the organization's environmental aspects and impacts. A thorough stakeholder analysis helps an organization understand their concerns, expectations, and potential influence, which is crucial for setting relevant environmental objectives and targets, and for communicating environmental performance effectively. The identification process should be dynamic, allowing for the inclusion of new stakeholders as circumstances change or new environmental issues emerge. This proactive approach ensures that the EPA is not only technically sound, but also socially relevant and accepted, contributing to improved overall environmental performance and organizational credibility. Question 22. Consider an industrial facility that has identified a significant environmental aspect related to its wastewater discharge, which is subject to stringent local regulations under the Clean Water Act amendments. The facility's environmental policy commits to continuous improvement in environmental performance. To address this, the management team proposes an environmental objective to minimize the impact of wastewater discharge. Which of the following would represent the most appropriate environmental target, aligning with the principles of ISO 14031-2019 and relevant regulatory drivers, and demonstrating a commitment to measurable improvement? Option A. Achieve a general reduction in the total volume of wastewater discharged by 5% annually, irrespective of pollutant concentration or regulatory limits. Option B. Conduct a comprehensive review of all wastewater sources and their respective pollutant loads to identify potential reduction opportunities. Option C. Implement a new wastewater treatment technology that is considered best available technology by the Environmental Protection Agency. Option D. Reduce the concentration of suspended solids in the final effluent by 15% below the current average, measured monthly, within the next 18 months, ensuring compliance with all applicable discharge permits. The correct answer is D. Reduce the concentration of suspended solids in the final effluent by 15% below the current average, measured monthly, within the next 18 months, ensuring compliance with all applicable discharge permits. Explanation: ISO 14031, 2019 emphasizes the establishment of environmental objectives and targets as a crucial step in managing environmental performance. These objectives are high-level statements of intent, while targets are specific, measurable, achievable, relevant, and time-bound, SMART, quantifications of these objectives. When setting objectives and targets, an organization must consider its environmental policy, significant environmental aspects, legal and other requirements, and opportunities for improvement. The process involves identifying potential areas for improvement, prioritizing them based on significance and organizational goals, and then formulating objectives and corresponding targets. For instance, if a company identifies significant energy consumption in its manufacturing process, a potential objective could be to reduce energy intensity. A corresponding target might be to decrease energy consumed per unit of production by 10% within 2 fiscal years, supported by specific actions like upgrading equipment or optimizing operational procedures. The effectiveness of these objectives and targets is then monitored and reviewed as part of the overall environmental management system. Legal requirements, such as emission limits set by environmental protection agencies or energy efficiency mandates, directly influence the setting of these objectives and targets, ensuring compliance and driving performance improvements. Question 23. A chemical manufacturing facility operating under stringent national environmental regulations concerning effluent discharge limits aims to enhance its environmental performance assessment. The facility has implemented a new process to recycle a significant portion of its wastewater, leading to a reduction in the volume of treated water discharged into the adjacent river. Concurrently, local environmental monitoring stations report a measurable decrease in the concentration of a specific chemical compound in the river, a compound that is also a byproduct of the facility's manufacturing process. Considering the definitions within ISO 14031-2019, which of the following classifications accurately categorizes the indicator percentage reduction in treated wastewater volume discharged per ton of product manufactured? Option A, Regulatory Compliance Indicator RCI. Option B, Management Performance Indicator MPI. Option C, Environmental Condition Indicator SI. Option D, Operational Performance Indicator OP. Correct answer is D, Operational Performance Indicator OP. Explanation: ISO 14031-2019 distinguishes between different types of environmental performance indicators, EPI, to provide a comprehensive view of an organization's environmental impact and management. Operational Performance Indicators, OP, are designed to measure the environmental performance of an organization's operations, processes, and activities. They focus on the efficiency and effectiveness of environmental management systems in controlling impacts. Examples include the amount of energy consumed per unit of production, water usage per employee, or waste generated per ton of product. These indicators are directly controllable by the organization and reflect its operational choices and practices. Environmental Condition Indicators, SI, on the other hand, are used to assess the state of the environment, both locally and globally, in relation to an organization's activities or other relevant factors. ECIs are not directly controlled by the organization, but are influenced by its operations and other external factors. They provide context for understanding the significance of the organization's environmental performance. Examples include ambient air quality levels, biodiversity indices in a local ecosystem, or the concentration of a specific pollutant in a nearby river. The key difference lies in the directness of control and measurement. OPIs measure internal operational efficiency concerning environmental aspects, while ECIs measure the external environmental state that may be affected by the organization's activities. Therefore, an indicator like the percentage reduction in hazardous waste sent to landfill, reflecting improved internal waste management practices, is an OPI. Question 24. An environmental manager at a chemical manufacturing facility is tasked with developing new environmental performance indicators, EPI, to monitor the facility's compliance with the recently enacted Regional Emissions Reduction Mandate, the Clean Air Act Amendment of 2023. The manager proposes an EPI, the perceived ease of reporting on volatile organic compound, VOC, emissions by plant operators. This proposed EPI is intended to indirectly reflect operational efficiency in managing VOCs, Considering the criteria for selecting effective EPIs as stipulated in ISO 14031-2019, which of the following is the most significant deficiency of this proposed EPI? Option A. It is not measurable or quantifiable in a consistent and objective manner. Option B. It is not accurate in reflecting the actual volume of VOCs released. Option C. It does not allow for comparison with historical data or regulatory benchmarks. Option D. It is not relevant to the direct environmental impact of VOC emissions. Correct answer is A. It is not measurable or quantifiable in a consistent and objective manner. Explanation: the selection of environmental performance indicators (EPI) is a crucial step in the environmental performance assessment process as outlined in ISO 14031-2019. Effective EPIs must satisfy several key criteria to provide meaningful insights and support informed decision-making. Relevance ensures that the EPI directly relates to the organization's significant environmental aspects, operational activities, or management system, allowing for a focused assessment of performance. Measurability implies that the EPI can be quantified or assessed in a consistent and objective manner, enabling tracking over time and comparison. Accuracy is vital, meaning the data collected for the EPI accurately reflects the environmental condition or activity it is intended to represent, free from significant bias or error. Comparability allows for the evaluation of performance against internal objectives, historical data, industry benchmarks, or regulatory requirements, facilitating trend analysis and identifying areas for improvement. An EPI that is difficult to measure, lacks a clear link to environmental impact, or cannot be reliably compared to other data points would not be considered effective according to the guidelines. Therefore, an EPI that is difficult to quantify and lacks a clear linkage to a significant environmental aspect would fail on both measurability and relevance criteria, rendering it ineffective for performance assessment. Question 25. When evaluating an organization's compliance with new wastewater discharge limits mandated by the Regional Environmental Protection Agency, which fundamental principle of data quality, as described in ISO 14031-2019, is most critical for ensuring the validity of the reported effluent monitoring results? Option A. The historical availability of data from previous reporting cycles, even if methodologies have changed. Option B. The perceived ease of data entry and reporting for operational staff. Option C. The statistical significance of the collected samples, regardless of their representativeness. Option D. The consistency of measurement methods and units across all sampling points and time periods. Correct answer is D. The consistency of measurement methods and units across all sampling points and time periods. Explanation: ISO 14031-2019 emphasizes the importance of data quality and reliability for effective environmental performance assessment. The standard outlines that the credibility of any assessment hinges on the accuracy, completeness, consistency, and timeliness of the data used. To ensure this, organizations must establish clear data collection methodologies, define measurement units and frequencies, and implement validation procedures. This includes cross-referencing data from different sources where possible and ensuring that any assumptions or estimations are clearly documented and justified. For instance, when assessing energy consumption, data should be sourced from utility bills, sub-metering, or calibrated monitoring equipment. Any discrepancies or outliers should be investigated to understand their root cause, which could range from instrument malfunction to changes in operational practices. Furthermore, the reliability of the data is enhanced by maintaining a clear audit trail, allowing for verification of the data's origin and transformation. This rigorous approach to data management underpins the validity of environmental indicators and supports informed decision-making for performance improvement. The principles of data quality are fundamental to demonstrating environmental responsibility and achieving the objectives of an environmental management system. Question 26. A chemical manufacturing plant, operating under a National Environmental Protection Act that mandates reporting on water quality parameters downstream of its discharge points, implements an environmental management system aligned with ISO 14031-2019. The plant identifies its wastewater discharge as a significant environmental aspect. To assess its environmental performance related to this aspect, It begins monitoring the concentration of dissolved oxygen in the river at a point 500 meters downstream of its primary effluent pipe. This monitoring data is used to evaluate the overall health of the aquatic ecosystem, which is known to be affected by the plant's operational activities. Which category of environmental performance indicator, as defined by ISO 14031-2019, best describes this specific monitoring parameter? Option A, Operational Environmental Performance Indicator. Option B, Indirect Environmental Performance Indicator. Option C, Management Environmental Performance Indicator. Option D, Direct Environmental Performance Indicator. The correct answer is B, Indirect Environmental Performance Indicator. Explanation: the core principle of ISO 14031-2019, specifically concerning the assessment of environmental performance, is the establishment of relevant environmental performance indicators, EPI. These EPIs are categorized into direct and indirect types. Direct EPIs relate to an organization's environmental releases to the environment, such as emissions to air or discharges to water, or the consumption of resources. Indirect EPIs, on the other hand, are measures of the environmental condition that can be influenced by an organization's activities, but are not direct releases or resource uses. Examples of indirect EPIs include changes in local biodiversity, ambient air quality, or water quality in a receiving body. The standard emphasizes that both types of EPIs are crucial for a comprehensive understanding of an organization's environmental performance. When an organization identifies its environmental aspects, activities, products, or services that can interact with the environment, it then determines the associated environmental impacts. Any change to the environment, whether adverse or beneficial, wholly or partially resulting from an organization's environmental aspects. The EPIs are then developed to measure and monitor these impacts and the effectiveness of the organization's management system in controlling its aspects. Therefore, an EPI that quantifies the reduction in the concentration of a specific pollutant in a river downstream from an industrial facility, which is influenced by the facility's effluent discharge, serves as an example of measuring an environmental condition influenced by an organization's activities, aligning with the definition of an indirect EPI. Question 27. When assessing an organization's environmental performance according to ISO 14031-2019, which classification of indicators primarily focuses on the effectiveness of management systems and the implementation of environmental policies and programs, thereby providing insight into the organization's commitment and actions to manage its environmental aspects? Option A, Environmental Condition Indicators. Option B, Regulatory Compliance Indicators. Option C, Management Performance Indicators. Option D, Operational Performance Indicators. The correct answer is C, Management Performance Indicators. Explanation: ISO 14031-2019 is structured into several key clauses that guide organizations in assessing their environmental performance. The standard emphasizes the systematic application of environmental performance evaluation (EPI) processes. Clause 5, Environmental Performance Evaluation, is central, detailing the steps involved. This includes establishing an EPE framework and implementing an EPE process. The EPE process itself is broken down into several phases: identifying environmental aspects and impacts, establishing objectives and targets, collecting and analyzing data, reporting and reviewing. Within this, the standard distinguishes between different types of indicators used for EPE. Management Performance Indicators, MPI, focus on the extent to which management is implementing its environmental policies and programs. Operational Performance Indicators, OPI, measure the environmental performance of activities, products, and services. Environmental Condition Indicators, SI, provide information about the state of the environment, often influenced by an organization's activities but not directly controlled by it. The standard structure facilitates a comprehensive approach to understanding and improving an organization's environmental footprint by linking management actions, operational efficiency, and environmental outcomes. The correct answer reflects the standard's categorization of indicators used to assess environmental performance, highlighting the distinct roles of management, operational, and environmental condition indicators in this evaluation process. Question 28. When assessing the environmental performance of a manufacturing facility that discharges treated wastewater into a local river, which of the following would most accurately represent an environmental condition indicator, SI, as defined by ISO 14031-2019, reflecting the state of the receiving environment? Option A. The number of environmental training sessions conducted for facility employees regarding wastewater management. Option B. The concentration of a specific heavy metal in the river downstream from the facility's discharge point. Option C. The total volume of treated wastewater discharged by the facility per month. Option D. The energy consumed by the facility's wastewater treatment plant per cubic meter of water treated. The correct answer is B. The concentration of a specific heavy metal in the river downstream from the facility's discharge point. Explanation. Environmental condition indicators, SI, are measures that provide information about the state or condition of the environment. They are distinct from environmental performance indicators, EPI, which measure the organization's performance in relation to its environmental aspects. ECIs are crucial for understanding the context in which an organization operates and for assessing the potential impact of its activities on the environment. ISO 14031, 2019 emphasizes the importance of ECIs in providing a baseline and for evaluating the effectiveness of environmental management efforts. For instance, a regional air quality index or the concentration of a specific pollutant in a water body are examples of ECIs. These indicators help an organization understand the environmental pressures it faces and how its operations might contribute to or be affected by changes in environmental conditions. The purpose of ECIs is to offer a broader perspective on environmental quality and trends, which can then inform the selection and interpretation of an organization's own EPIs. They help in identifying significant environmental aspects and in setting relevant environmental objectives and targets, ensuring that the organization's performance assessment is grounded in the reality of the environmental conditions it influences or is influenced by. Question 29. A manufacturing firm, Veridian Dynamics, is undergoing an audit of its environmental management system based on ISO 14031-2019. The audit team has identified that, while Veridian Dynamics has established a target to reduce hazardous waste generation by 15% over the next fiscal year, the actual reduction achieved in the first quarter was only 3%. During the check phase of their EMS, they reviewed the waste manifests and interviewed operational staff. What is the most appropriate action for Veridian Dynamics to take during the ACT phase, considering the principles of continuous improvement and the guidelines of ISO 14031-2019 for assessing environmental performance? Option A. Focus solely on increasing the frequency of waste audits without altering current operational procedures for hazardous waste management. Option B. Initiate a comprehensive review of the entire EMS, including the environmental policy and the identification of environmental aspects, to determine if fundamental flaws exist. Option C. Reevaluate the initial target, lowering it to a more achievable 5% reduction for the fiscal year based on the observed first quarter performance. Option D. Implement revised waste segregation protocols and conduct targeted training for personnel involved in hazardous material handling to address identified inefficiencies. Correct answer is D. Implement revised waste segregation protocols and conduct targeted training for personnel involved in hazardous material handling to address identified inefficiencies. Explanation. The Plan Do Check Act (PDCA) cycle, also known as the deeming cycle, is a fundamental iterative four-step management method used for the control and continuous improvement of processes, products, and services. In the context of ISO 14031-2019, which provides guidelines for assessing environmental performance, the PDCA cycle is crucial for establishing, implementing, maintaining, and improving an environmental management system, EMS. The plan phase involves establishing objectives and processes necessary to deliver results in accordance with the organization's environmental policy. This includes identifying environmental aspects, impacts, legal and other requirements, and setting environmental objectives and targets. For instance, an organization might plan to reduce its water consumption by 10% within a year. The Do phase involves implementing the processes defined in the planning phase. This is where actions are taken to achieve the environmental objectives. Continuing the example, the organization would implement water-saving measures such as installing low-flow fixtures, optimizing irrigation, and training staff on water conservation. The check phase involves monitoring and measuring performance against the established objectives and targets. This is where data is collected and analyzed to determine if the implemented actions are effective. The organization would measure its actual water consumption and compare it to the planned reduction. This phase also involves reviewing compliance with legal and other requirements. The act phase involves taking actions to improve performance. If the results of the check phase indicate that objectives have not been met, corrective actions are taken. If objectives have been met or exceeded, the organization considers how to sustain the improvement or set more ambitious targets. This might involve refining the water-saving measures or exploring new technologies. The PDCA cycle is a continuous loop, ensuring that the EMS is constantly reviewed and enhanced to achieve better environmental performance. Question 30. When an organization seeks to integrate its environmental performance evaluation (EP) process, as guided by ISO 14031-2019, with an established quality management system (QMS) that adheres to ISO 9001 standards, which strategic alignment best capitalizes on existing organizational structures and processes for enhanced efficiency and effectiveness. Option A. Focusing EPE integration solely on the environmental policy statement, without linking it to the operational controls or performance monitoring within the QMS. Option B. Developing entirely new data input forms and reporting templates specifically for EPE, distinct from any existing QMS documentation. Option C. Leveraging the QMS's established data collection, analysis, and management review procedures to incorporate environmental performance indicators and data. Option D. Prioritizing the auditing of environmental compliance through the QMS audit program, neglecting the broader assessment of environmental performance trends and improvement opportunities. The correct answer is C. Leveraging the QMS's established data collection, analysis, and management review procedures to incorporate environmental performance indicators and data. Explanation. ISO 14031-2019 emphasizes the integration of environmental performance evaluation (EP) with other management systems to achieve synergistic benefits and a holistic approach to organizational management. When integrating EPE with an existing quality management system (QMS) conforming to ISO 9001, the primary focus for effective integration lies in leveraging the established processes for data collection, analysis, and continual improvement. The QMS already provides a framework for defining objectives, monitoring performance, conducting audits, and implementing corrective actions. By aligning EPE indicators with quality objectives and using the QMS's data management and review mechanisms for environmental performance data, an organization can streamline its management efforts. This integration avoids duplication of effort and ensures that environmental considerations are embedded within the overall operational and strategic planning of the organization, leading to more efficient resource utilization and enhanced overall organizational performance. The core principle is to utilize the robust structure of the QMS to support and enhance the EPE process, rather than creating a separate, parallel system. This alignment facilitates a more comprehensive understanding of how environmental aspects impact product or service quality and customer satisfaction, and vice versa, fostering a culture of integrated excellence.